Please record. Well, good afternoon, everyone. Welcome to today's session on resilient and sustainable supply chains, harnessing data analytics and AI. So, as you might know, over the past years, we have lots of global disruptions that impact the supply chains and transportation. Right? Pandemic, we had geopolitical conflicts like the wars. There are climate events, disasters. So those all impact supply chains and transportation systems and manufacturing networks. So these challenges have not only tested the resilience of our systems, but also wanted us to be more sustainable, more resilient in the long term. So in today's session, we will talk about how we can use data analytics, AI, detection, machine learning tools to improve resilience along supply chains, transportation, and manufacturing network, and also improve sustainability. Because resilience and sustainability go hand in hand, so we cannot compete to separate them. So we will look at why resilience and sustainability should go. How do we define resilience and sustainability? Maybe I will start with that. And then what are the emerging technologies that shape supply chain, transportation, and manufacturing, and how they can be used to improve resilience and sustainability. And we encourage your engagement, so you can give comments, ask questions anytime, if that's okay with the panel.
No.
Yeah.
I think we're intimate enough to
Yeah.
allow for this, have at it, right? By the way, are the people on the video are they able to hear us?
Yeah, I can hear you very well if you can hear me.
Awesome.
Yeah, we can,
That's
Patrick.
perfect.
Thank
Great.
We
you.
have two people from Emerson online,
Okay,
right?
awesome.
So
Tour one.
I have two people.
There's one on now from Emerson. I'm Patrick Gibbons. I'm president of our Emerson Healthcare, our supply chain and distribution company. And Frank Davies going to be joining momentarily. He had like a 15-minute delay for a call that's running over.
No
Awesome,
worries.
Awesome. Thank you, guys.
Thank
Patrick.
you.
for being here.
You're welcome.
And the panel, thanks. We are honored to have you. I'll let you introduce yourselves. I think I will try. We have identified she's an experienced supply chain and FPA leader with proven track record in improving operations, logistics, and procurement, enhance efficiency and support business objectives. With over 7+ years in supply chain management at FPA, she applies a practical, results-oriented approach to reducing costs, fostering collaboration, and increasing end-to-end supply chain visibility. Very important. And then
Yes. The company, I'm the founder. We're a solutions company where we specialize in, CPGs, manufacturing, retail, and help companies come up with the solutions within supply chain and demand using automation, AI, and machine learning. So we do a lot of demand sensing, forecasting, and help companies, but having a better forecast accuracy, bring back money into the EBITDA.
thank you. And then we have Dr. Chin. He's visiting us from University of Tennessee in Knoxville. He is the John Tickle Professor and Department Chair of Industrial Systems Management at the University of Tennessee, Knoxville. And he directs the Institute for a Secure and Sustainable Environment. And he's the PI for the principal investigator for the Center for Freight Transportation for Efficient and Resilient Supply Chains, which is the University Transportation Center funded through U.S. Department of Transportation. It's a tier 1, so that's a big center, right? And he does research in sustainability, supply chain, logistics, climate change, alternative energy, among many other things. He has lots of papers from articles, 120 plus.
Oh, well.
Yeah, and then lots of grants, more than $25 million. And he serves many journals, editorial board as well. We are happy to have you. Anything that you want to add?
No, well, not really. Thank
Not
you.
really? Okay. And then finally, we have Shri Murthy.
Yeah.
Right? Shri is a seasoned global entrepreneur, PML leader, bridging technology and discrete manufacturing. He's an expert at digital twin, which is a really important concept recently, right? And then factory of the future, PLM, digital manufacturing, and using AI for manufacturing as well. He has consulted lots of companies. He consulted to CXOs at market manufacturing sector, clients across a variety of industries in 19 different countries. He also advises early stage companies focus on using AI and machine learning to solve problems. Shri,
I don't think I have anything else, but to say that one thing is AI is not something new. So the first time I worked with AI was in the mid 90s, right? We used to call them expert systems. We used to call them knowledge-based engineering, for those of you who kind of remember that. This is just a new avatar of that, right? The second thing is, as far as digital twins is concerned, the first time I showed 400 cars running down the assembly line, right, in a virtual environment, to the then CIO of General Motors, Ralph Segunda, was in 1999. So digital twins is also a very, very old concept. It's just it's getting more now because of computing power and everything else. And we did those things in those little bitty PC XTs and whatever else, right? We hardly any power. Now you can do a lot more.
finally, I'll be the moderator of the panel. I'm Dr. Jason from Information Systems and Department. I work in supply chain modification. Again, thanks, and we will start with definitions of resilience in supply chain. What is resilience? What is supply chain sustainable?
Well, how easy it is for companies to adapt in the midst of disruptions, right? I think recently, we've dealt with a lot of natural disasters, global trade changes, the most recent tariffs, which I think is something that everyone is talking about. At least our clients are talking about it, and what do we do about it, and how do we become more resilient with that, and kind of where do we look, where are the suppliers, diversify that area of the supply chain, and yeah, I think being ahead of the game and adapting faster and quicker to this disruptions. I think that's what makes a resilient supply chain.
For me, when somebody says, when you spoke about this, right? One is resilience and the other is sustainability. And I'm thinking, it's kind of this pull push thing going on, right? If you increase your resilience and your ability to be resilient, there is a danger that you may not be very sustainable in terms of, or your points in terms of sustainability out. Because take, for example, COVID-19, right? Everybody that had transportation and things that were just working perfectly, all of a sudden when you switched off, their industries went down almost overnight, right? So when you look at that, there were other people who didn't very much suffer. And we can talk about examples, but there were people who had already stockpiled inventory because they were not into the new age systems of just in time and the Toyota production systems and so on and so forth. So when they were not into that, they just old school. They were not very, and several of them actually built products closer to where they were, right, where the customer was. And a lot of times, you don't do this with a holistic view, and sustainability points kind of go down. So your ESG function within your enterprise, they feel the pain a little bit, right? So this is kind of two parts to this fabric, right? One pulls, the other one pulls.
Jet models,
Yeah.
just in time, where it worked for Toyota,
Yeah.
and it was fine, but for other companies, it kind of brought them into looking at new stock management, new stock out rules that kind of had to adapt and essentially be resilient towards that, or go local,
Right.
right? Or look at other different suppliers that were local and all that. But
See,
yeah,
you talk about Toyota, right? The reason that Toyota didn't feel the pain as much as the others did, it's not that they didn't feel the pain. Obviously, everybody felt the pain. COVID-19, right? But Toyota had learned from the earthquakes and the natural disasters that happened in Japan in 2011, right? So they learned from that, and they had already stockpiled all their chips, and because of that, they didn't hurt as much, right? Even after COVID-19, we had the chip shortage.
Right.
They didn't have it, right? So it again, it depends on whether you learn and how you go about it. But
So of course, I'm from academia, so for her, I understand your patience. So yeah, we have already had some kind of a scientific definition of resilience for many years. So it's basically, it's a probability of happening, then the probability how easy you can detect it, then the loss of each disruption. So when you talk about loss of disruption, so typically we have like this kind of curve. So that's okay, normal level. So you have a shock, you have a disruption, go down. Hopefully they will recover and go up. Of course, you have already taken calculus. So actually the area, so it's about how fast you can recover,
Respond, yeah.
but also when you about how long you can recover and how much you can reduce, right? That kind of depicts the loss and how fast you can come back. So that area is defined as the expected loss times the probability that it will happen, and also times how fast you can detect it. But if you cannot detect it, also you will have more loss. So that's okay. The scientific definition for resilience. Talk about sustainability. Also, the definition we always talk about three pillars: social, economic, and also environmental. So most people pay more attention to environmental sustainability. Yes, of course, I'm directing Environmental Institute, but also please don't forget economic sustainability and also social sustainability. For me, sustainability is really about people. I know many people think it's about environment, because do we really care about the environment, for example, on Mars? Does it matter? Of course, the environment is terrible, but no people are there. Why do you worry about it? So we really talk about environment, because also perhaps okay, when we talk about it's a good environment or bad environment, it's really about the human being. Maybe the current environment is not good for dinosaur, but do we really worry about dinosaur regarding environmental sustainability? So for sustainability, really about how we can make people, human being, for this generation, also for the future generation, because I don't care about my kids, and I don't have 2 kids yet. So that's okay about the sustainability, how we can still make sure that they could be okay economically successful and have a good life and also have a healthy life. So that's the definition of sustainability from people, not only from environment. So that's okay about the sustainability. Yes, I agree. There's always some trade-off between that. We have a lot of discussion on just in time. I think 2011, actually, the earthquake, I believe, I could be wrong, it happened in Southeast. So yes, all the automotive industry was highly disrupted because one small part, very small part. At that time, most automotive companies used a supply chain strategy called single sourcing. If you have ever taken supply chain management, it was single sourcing. So that no matter it was Toyota or it's a Honda or it was Nissan, they had that part from one single plant in Thailand. Because of the earthquake in, I think, Indonesia, and there was a resulting tsunami influenced Thailand, that plant was disrupted. To produce a car, you need all parts. You just cannot miss one part. So that's why during that time in 2011, there was huge disruption on Japanese makers all around the world. So after that, we are also, you and I teach supply chain, so we talk about the dual sourcing. Yeah, dual sourcing, multiple sourcing. Yes, if you know reliability, right? If reliability of one sourcing, single sourcing is 90%. If you have dual sourcing, actually your reliability is increased by, in two, actually 99%. It's a very simple math, right? 1 minus 0.1 squared. So it becomes 99%. Pandemic gave us a very, what's wrong with that equation? So are you with me? So if, okay, single source, the reliability is 90%. When we dual sourcing, the reliability will be 99% because it's 1 minus 0.1 times 0.1. So you get 0.99. But there's an underlying assumption for that calculation. So what is the underlying assumption? The disruptions are independent from each other. So you assume that, okay, you have two sources, they will be disrupted in an independent way. If you have already, you can still remember probability. Pandemic is completely different thing. It was a systematic disruption. We never modeled that from supply chain kind of okay, research viewpoint, because when it happened, it impacted all kind of okay, logistic channels and also all kind of manufacturers. So we never really, so the actual reliability is not 0.99 because all of them actually were disrupted. That was a huge okay lesson we learned. We just cannot use this kind of model by adding more kind of sources to improve reliability so much. So yes, we talk about increased inventory. Another way is actually global supply chain. The chains are too long. Maybe, so we perhaps okay, need to have more distributed supply chain, reduce the links. So all of okay, the chains we call it. So that's also all things. And also after you reduce the chains length, you also improve sustainability a lot because we still emit a lot of carbon emissions through transportation. Transportation has not been well kind of okay, electrified, so we still have a lot of carbon emissions compared to manufacturing business. That's too much.
No, that's
Great.
I mean, especially supply chain being long is important, right? The transportation is generating also emissions. Even if you have multiple suppliers, they might be working with the same supplier themselves.
That's
So the resilience is not just your next level, right? It's the whole global supply chain network that might impact your resilience. So I was looking at some data, like for instance, the shipping cost increased like 400% during pandemic from China to US.
Oh, yeah.
400%. That's crazy. If you are doing outsourcing, your main idea is to decrease the cost, but with that increase in the shipping cost, it doesn't make sense anymore. But you can become local, then you reduce the transportation amount, so you can become sustainable while also becoming resilient. So I understand your point here, like you say.
It's
one.
again, it's a fabric that's pulling against
Yes.
each other, right? And even the human element, as Dr. Ming had said, that that's also pulling on one direction, and you can't make an entire region unemployed, right?
That's
Right.
Right?
That's
And
also-
because of
so
some of
true.
these things, right? So, and to that single sourcing issue, yes, everybody said, oh, single sourcing is the best thing.
Yeah.
And, we saw the effects of it. I mean, 2011 was Fukushima, right? And before that, also during the tsunami of 2004,
Okay, that's 2004.
yeah, and I mean, everybody understood that. And whenever they look at it, and this is not a new thing, right? World War II, I would argue, started because of this interdependency of economies and relationships between different countries in terms of trade, right? That I mean, and that happened. I mean, but we didn't learn from it. So we keep kind of making the same sort of mistakes, more sophisticated, but sort of mistakes in the same, in the same century, really.
But I think where it has kind of changed as well is technology, right? And this is where I think we saw this with our company in 2019. We're a tech, virtual prepared, all about data, solutions, already working on data cleansing and AIs and machine learning algorithms. And we had companies that were prepared with technology, right? So when that hit, they didn't really see much of a loss, right? They were able to get, everybody on board. A lot of these guys had, multiple suppliers, some of them local, in a smaller basis, obviously. But the biggest thing was technology. They had the technology, they had the data, they had the analytics to be able to apply, models that and what if scenarios. Talking about risk assessment, that has been a huge thing we've seen in the last since 2019.
Yeah, and
where
that's my next point.
yeah, which is the digital twins, right? The digital twins on the supply chain, having running this multiple virtual supply chains with what if scenarios without affecting the real operations of all the factories and everything, right? And I know you can talk a lot more about the digital twins since you have a lot, especially in
But
manufacturing.
in terms of supply chain itself, right? In terms of
Right.
transportation, you remember the Suez Canal situation?
Yeah.
6 days, a ship stuck in the Suez Canal at an angle, and it stopped like 400 ships behind it. I mean, how do you simulate that?
Right.
Well,
and
think
that-
about that, like it delayed over 9 billion of goods daily.
Right.
Yeah.
Right.
9 billion.
But think about real-time tracking
Yep.
software now, solutions, right? Where you can essentially track your load from point A all the way to point Z, right? There's products like Kites, for example, E2Open, or the GeoWeb, I think it was a Geotech. I mean, they're all able to track in real time where the goods are. And that's huge, right? But yeah, I think the technology, the solutions, the data, being able to see real time and kind of adapt and faster
Yeah, so
than we
that's
usually
my next
do.
question to you.
Yeah,
How can we use data and AI to become resilient, to become sustainable?
right. Well, so you look at sustainability practices, right? I think one of the interesting things for me is the green transportation, right? So we're using electric vehicles, energy powered devices. You got drones, you got different like biodiesel, for example, biogas, right? So there's a lot of tech being used to innovate, to become resilient and also sustainable, right? I don't know if you have to add, something different on the manufacturing side or warehousing, for example, right? I mean,
Can you like extend the definition of digital twin from?
I asked you, and it's like,
Yeah. I mean, digital twins, to be honest with you, is many things to many people, right? And it depends on who you're asking. It's like, that story that we were told as kids. There are 10 blind people or blindfolded people in front of an elephant, and each one touches the elephant, and then they say, "Oh, this is this, that is that." I mean, based on what they're touching, right? Nobody's seeing the whole thing together. So, in a similar way, when you talk about digital twins or even this overused phrase of digital transformation, right? Everything is different for it's context specific, right? So if I have a whole lot of data coming in from several IoT devices on the shop floor, and I can visualize it even on an Excel or a table kind of format, that is the digital twin of that data, right? Of that machine process or whatever else is sending this data, right? That's one aspect of it. The aspect that I grew up with, cut my teeth in, is to create 3D assets of the actual product or plant or whatever else that you're building. So these days, when you're shopping for a house, right, a new house or whatever else, you're flying through these models, right? These photorealistic models. What are they? They are digital twins, right? But beyond just pretty pictures, you want those models to actually be relevant from an engineering standpoint. Because I want to be able to do CAE analysis. I want to be able to do crash testing. I want to be able to do, you know, temperature variations on that particular piece of equipment, or, you know, passing electricity through a particular circuit. If I change a few parameters, does the heat increase, for example? Take for example, airplanes, right? A lot of composites are being used in airplanes, and there is so much of cables and wiring that goes into an airplane. It is shocking, right? But these cables generate tremendous amounts of heat. It is shocking how much heat they generate. And so the fact that your engineering structures have to be able to withstand that is very important. Now, gone are the days when you could actually build a prototype and then test it to a limited extent and then go beyond it. These days, even for something like, gosh, you know, the last plant, you know, when I visited Jaguar Land Rover's facility in the Midlands in England, they had, they were using software to simulate, you know, going through a large water, you know, on the road or in an outdoor area, right? They're trying to figure out where the water splashes. Other than doing it physically, there was no other way to do it. These days, you use CAE to do that, right? So all these things are digital twins, right? I could open up my phone right now and show you a proper manufacturing facility, which looks remarkably photorealistic, right? And you can fly through it, you can measure, you can do various things, you can move things around, you can take an operation from station 25 and put it to station 72 as you're balancing all these things. And you're doing all this without laying a single brick on the ground, right? That's the digital twin. Now, if you extend that to, people have watched these movies with you know, trains going berserk, right? I mean, no driver in the train and all kinds of things happening, and somebody in the control room looking at all these lights going, right? That's kind of the digital twin flavor to it, right? Now, if you had an actual model and you made changes to the model, and that told you what the result will be in terms of production or in terms of you know, how the line would run. And the bigger thing is, if that information could be transmitted to the shop floor, and then that controlled the machines, that is what everybody's trying to reach for. And that's the holy grail. And nobody's really done much about it at this point, because it, again, is the cost benefit thing. So they're trying to figure out how to build sustainably, you know, efficiently, so that they can make profit. And then eventually these technologies will come. Like I said, digital twins have been around for at least 25, 30 years. And their adoption is only now kind of slowly going up because of computing availability. I don't know. I mean,
Yeah,
beyond
that's
this,
a good-
Yeah,
yeah.
I mean, I know one application. I think DHL network. They can see all the containers they are carrying. If there is something going on, they can make you like
Real
for
time.
instance,
Real
sometimes they carry vaccines, right? And they are coming. The shipment needs to go through Arizona. There's a heat wave there. They know that at that time, and they can tell the truck driver to wait or, you know, change to routes so that, you know, it doesn't go through that heat because they are carrying vaccines.
Yeah,
that needs to be.
Right, the automated route planning.
That's kind of, it's not only the system, but also like there are different layers, right? There's network, there's the weather that you can put on top of your own system and make decisions. Anything that can affect your operations can be integrated into digital twin.
yeah,
Yeah,
absolutely.
absolutely,
So,
100%.
So for me, okay, digital twin has 3 levels, and originally, I don't know how many people have ever taken a course called simulation, or computer simulation. One, okay, so yeah, so of course, we had simulation models for many years.
Right.
The computer simulation model, and create discrete simulation at the beginning, and then later also some agent-based simulation, different simulation. So if you have any kind of simulation background, you know what you typically do. You need to input analysis. So you have historical data. You analyze the data, understand okay those parameters, and also get the distribution of those data. For example, it's a normal distribution with a mean of 3 and a standard deviation of 5. You build the model, represent the complicated logic, then you run it, then you do output analysis, right? Simulation course. So you still say, okay, if I change my from manufacturer, change my layout, what is the impact on my throughput or other things?
Yeah.
Or maybe I change, the sequence of my process, what's the impact? So this is a classical simulation. Then the second,
You're talking about discrete image simulation.
it could be also agent-based simulation.
Yeah.
So there could be some dynamics. So for me, that's the first level. So you can see that, especially for AI. So we do analysis through AI, through statistics. Before we build the model and also run the model. The second level is that if you still know that simulation, there are a lot of terminology, right? You know entity, and also know states. So simulation model could be wrong. So they may not capture the actual states very well. So if you have real-time sensor, and that's also
Which
another
is
thing.
demand sensing.
Yeah, I have
Yep.
real-time sensor and also real-time communication. So the second level of kind of digital twin is to adjust your states based on your collected data. For example, based on simulation, your inventory level is 5, but actually because of the high demand, maybe your inventory level is 1. So you can adjust it real time for your simulation. Make sure that your simulated states actually represent the reality very well. The third level is a little bit different. It's about the learning. Well, you still make a lot of assumption, right, for your simulation model, but could be your assumption was wrong, or could be your underlying kind of reality has already been changed. So for example, we still talk about transportation, right? We talk about arrival rate. Maybe because of population growth, your arrival rate is different. It's not like, 1,000 vehicles per hour for that intersection. Could be already 1,500 vehicles an hour. So you should have a capability to collect real-time data and also learning. So not only change the state of your simulation, but also change your underlying distribution of assumptions. So that's AI kind of capability. So now the system not only represents the real states, actually your real model, the model represents the real system much better. So for me, that's the kind of digital twin, real digital twin. Of course, it requires a lot of computational power, computer computational power, data collection kind of capability, combination capability, then also implementation.
Yeah.
So we can do that.
Well, yeah, speaking about the data, right, and applying these models and
Right.
algorithms, it's fascinating for me to see little big companies, they don't know where their data is, or they have it,
No.
but they don't know how to get to it, right?
Yeah, that's very good.
Or they get to it, but it's not good data, right? We say garbage in, garbage out. So your algorithms and your results are as good as your data is, right? And therefore the simulations as well.
Yeah, absolutely.
Which is huge. And I think a lot of companies were talking about this. Right now, they still don't have access to the data, and they don't have clean data, right? And
No, you're right. You're
It's-
right.
yeah.
I don't want to interrupt. But see, the thing is, you make a great point, right? The manufacturers and companies that I talk to, we've got a lot of data. Do something with it, right?
Here you go.
Solve our problem. Reduce our costs. I mean, increase our EBITDA. And what do you want to do with this data, right? I had in my program management team, I had this kid who was excellent at reports and graphs and all kinds of things. And we had him on the team because he was very creative with all this. Okay, so gave him a lot of data, and he came back with these brilliant reports. And I'm looking at the report and I'm thinking, okay, what are you conveying? What is it that you want to? I mean, because you had data, you just put graphs and this and that. And if there is no background to what you want to solve, what you're trying to look for, what is the needle in the haystack that you want to identify, then all this,
It's-
visualization is kind of useless, right? So it depends on what people want to do, right? So effectively, I tell our customers, can you, yes, it might take maybe 15 years to do it manually, but can you solve the problem if you had all this data, right? You would say, okay, I would take all this data, I will sort it, then I will take the top 15. And if you can lay it down, then yes, then we know that you have a methodology to solve the problem. I can then feed it to an engine and say, okay, from all this data, cull this information out, the relevant information out, and then do something with it, right? Then that makes sense, right? Then you can actually get some value from it. Otherwise, like you're saying, garbage in, garbage out, and a whole lot of people, and even for simulations, right? You're right. And so I worked on these launch teams for these automakers, right? Uh, they would be doing certain things, and suddenly they would say, okay, we're going to install the fuel tank at this, whatever, station number 27, right? Okay, great. And everybody's like, oh yeah, we do this in Kansas City, and yeah, it'll work, right? And then somebody says, wait a minute, for the fuel tank, your sill height is going to be 2 feet, right? Because of the conveyor running up. So what do? We'll raise it up and then we'll lower it down. You lose 2 stations. Oh, okay. Yeah, we can do it. And then somebody says, you know what? Please have the simulation team verify this. Okay? The simulation team is given all this information. They input all this data. They simulate it. 3 weeks later, they come back saying that, no, you guys are full of it. This won't work. You just lost, tons and tons of work already done in these 3 weeks. And to your point, Dr. Ian, getting that loop, right? And have a live simulation constantly advise the digital twin is going to be critical going forward, right? And the kind of simulation that we spoke about is just one thing, right? It's discrete event simulation, among other things. Then there are simulations that are not stochastic in nature, right? Then there is human simulation, ergonomics, right? You can place a human. So for any operation to be done on a shop floor, you want to be able to make sure that it can be done by the 5th percentile female to the 95th percentile male. So somebody that is 4 feet 8 inches or somebody that is 6'6" should be able to do that particular job just with as much ease without any major problems to their L4, L5, in many ways, right? So you want to be able to do that. So that's all in human simulation. And then there is robotic simulation. If I have a whole slew of robots, how would they interact and work together to produce an end product? Digital twins are being created from each one of these. And if you have actual assets on the field, then it absolutely makes sense to make sure that those assets are retrofitted if they are old assets, or have those assets send the IoT information, or as much as possible in terms of surface finish or operations being done, or quality, or whatever it is, back to the mothership, if you will, and that says, okay, we're going to, alter these few parameters to make sure that we take into account these changes from the shop. So this closed loop thing is understated, to be honest with you, in most manufacturing companies, because they are so. This dichotomy is shocking. On one side, they're using digital twins and they're using these amazing processes to create these products. On the other side, they have some technologies, they are so far behind, right? And you're wondering, is it the same company, right? And so everybody's trying to elevate the whole company digitally, right? Improve their digital maturity. But at the same time, so they're saying, well, all this is great, Sri, but let's first fix our home, right? Get all these things up, and then we will get into all that wonderful digital twin stuff.
About AI.
Not really.
Uh,
I have some papers.
what's gonna happen?
I mean,
Is
it's
it gonna
such-
help the resilience of that? If some 70% of companies are excellent.
Just,
Okay, cool.
repeat that again.
70%.
Okay,
70.
AI adoption, supply chain management at a rate of 45%.
Certainly, I
We-
mean,
So
yeah,
what's gonna happen?
We-
Because sustainability has, we talk about environmental, and economic and social aspect. Some people talk about cultural lines, or bottom lines. From the
You're right.
social, AI, are we losing jobs, are we gonna, what's gonna happen? Big thing. Too big a concept, and anybody can
Okay.
jump in with
I-
information.
I'll start with the engineering and manufacturing piece a little
Okay,
bit,
yes.
and then
Yeah, I'll
Odita can
start.
talk about the other elements. I'll give you an example, right? AI absolutely will help, right? We cannot ignore it. It's about the ability, the superpower that we have that can analyze huge amounts of data, distill it, figure out what's important, what's not, and then apply it to simulate different kinds of problems that we are trying to solve, right? So whether it is simulating supply chain, what happens if there is, war between these two countries and that strait in the sea, that gets closed. Okay, how would material travel in a different way? Okay, that's one way of solving the problem. The other is near sourcing. Okay, what if we cultivate a bunch of suppliers nearby that could actually help solve that problem, right? I mean, so AI is going to absolutely help in solving all these problems. But from an engineering standpoint, from a manufacturing standpoint, supply chain is such a bloated, uh, how do I put it? Uh, base, right? For most of these companies. I'll give you an example, and maybe our friends at Emerson can resonate with this. So I was talking to I did a few projects for Schneider Electric, and so they were telling me that it's easier for an engineer to design a new part or to write a piece of code than it is to find something that's already been designed that can be reused here, right? You know why? Because engineers, as it is, spend 70% of their time looking for data. Okay, 70% of the time looking for data. And that has not changed in the last at least 18 years, right? It's become easier now, right? And so, which is why the proliferation of PLM systems and EDAs and all these other systems started coming in and they started integrating. So the group CIO of Schneider tells me, right, if we reduced part count in terms of duplicate parts, right? So they showed me some of these parts that were almost exactly the same part, like 30, 35 different part numbers, right? You could actually eliminate 29 of them and keep one part number, right? And make sure that all the products using it uses that one part number, right? But again, because people couldn't infinitely wait and search and find something, right, that they could reuse, you find this issue where people have been redesigning. So if you can reduce the part count by 2 to 3%, you could easily save upwards of $300 to $500 billion. Sorry, 500 to 300 to $500 million, right? So there's so much of money in there, right? And it's not humanly possible, and that's where AI will come in, right? So we will analyze images, right? And say, okay, look at all my databases and look at all the images and see which ones are the closest and say, okay, this is probably the same part, right? Or the same function. Okay, this flange that has been created and I have 17 different kinds of flanges. Maybe we figure out this one or two that can be used for everything that we have, right? So it's, I'm just giving you examples that are relating to supply chain and logistics and all that. But, AI is not going to go away. The faster we figure out how to use AI to solve our problems, I think the better it'll be. And step one is to document the problem and say, I think if I were a superhuman and if I had to do this thing manually, then I would take this data, I would do this, I would do that, and lay it out, right? The solution, and then AI can help give it more realistic output.
One example I have is like Walmart AI agents
Well, that's what I
to negotiate contracts with their suppliers, and AI agents do better job than the
right. So this is where I was gonna go, right? Because there's such a big AI hype, but are we there yet? Right? Like there? No, because to your point, you're dealing with the data. You're dealing with the engineer that's spending 70% of the time trying to figure these things out, right? But the data, they don't even have the access to the data. So where AI is, it's not going to go anywhere, right? So the question is, how do we coexist with AI to help us become more efficient, more resilient, and sustainable, right? So to your point, where we see AI being used is a lot of taking that 70% that engineers, spend, reducing it to, 30%, where they're actually, it's automation, right? Using the agents, using platforms for example, for demand sensing, consumer trends and insights, right? I mean, there's real-time solutions that we actually have that we connect to TikTok and Instagram, and a video, the moment the video goes viral on a pair of shoes or the sandwich guy, the chopped salad sandwich guy, you can tell right away that you can predict the demand just by that video, right? And what people are spreading out there, or if someone bought a bottle of wine, produced by X winery, and they went and grabbed a Barilla pasta, and then they went home and they posted, and I said, hey, we're a date night, and I'm making this recipe. Well, guess what? That's what people are buying that product for, right? Those are real-time consumer trends and insights and data that you can use AI to kind of predict some of this demand and become better at the forecasting side of it, right?
Yeah,
So,
like at that point, I have an example. Target uses the data to estimate from shopping behavior of women if they are pregnant,
right,
and at what trimester they are, and accordingly they send promotion coupons, because I think pregnant women shop at most when they're in the second or third trimester. So times the promotions as well.
right. Well, same thing with diapers.
Yeah.
Pregnant women, or the same thing with millennials or Gen Zs when they buy something that's targeted towards them, or maybe not, right? And we also see a lot of, for example, the Nielsen traditional survey companies. Those are old and so expensive, and with AI or being able to connect real time to this social media on Instagram, you're seeing what actual people are doing, not what they would do if they went and bought this, because that's what this traditional survey companies do.
Mhm.
And plus, you also have to wait weeks to get the results, right? Meanwhile, with AI driven and advanced algorithm tools, you can grab it right away, and it takes you 2 days, to get the results, and even a way bigger pool of people, because you're going and scanning through, Instagram and Facebook and Uber Eats and you name it, favorite and all that. So, I think AI is great. I think there's a lot to be done from a, security perspective, right? And also, yep, go ahead.
See, no, I was just saying that I think, and when we talk about use of AI, most of our vehicles are now becoming SDVs, right? Software-defined vehicles. So these auto companies, believe that they're going to make more money out of the subscriptions from the software than actually selling the car. Okay, so and AI is going to be, absolutely out there to actually figure out what the user wants. The moment you get in, it says, okay, drive to work, because you've been doing this every day. It's measuring that and saying, okay, drive to work is this. I don't know how many of you have watched this A Day Made of Glass video. Look it up on YouTube, right?
Great video.
There's a part 1 and a part 2. It's called Day Made of Glass. This was made way back in 2011, 2009, or whatever, right? Maybe at least 12 years ago. And it's remarkable how technology is advancing, right? So, you know, from a using AI standpoint, all these things that's going to happen. I mean, there's no way around it. But that being said, people have to understand AI cannot solve every problem, right? Why? Because AI is fundamentally a probabilistic solution, and you can't just throw it at highly deterministic problems to say, oh, you know, solve it. Okay, at 98% accuracy, this is the answer. I don't want 98% accuracy. I want 100% accuracy on certain things. And again, the question is, there are other tools, right? There are CNNs that you can use. There are traditional, heuristics that you can use. There are computational methods you can use. Those are great, right? And we all kind of put this cover of AI on everything. Yeah. But traditional AI or Gen AI is not, you just can't say, oh, we've got a whole lot of stuff to be resolved and solved. Let's just use AI. And I think, yes, please.
Well, Cider, I don't know if you're Cider. Cider is an amazing example of what you're talking about, where they have all built-in AI models and you subscribe to it and they have deep research and all that. Look it up. I mean, I use it because I think it's really neat because of what you're talking about, the flexibility of kind of how that, for me, it's interesting because how does the question that I'm asking, the answer that comes back on the question that I'm asking is different through all of these models, and then Cider has its own little algorithm that is a combination of all these, right? So yeah, right. So check it out. It's a really great, yeah. They have it for the iPhone too.
Question. Based on whether it's open source or companies based on now, if you are talking about sustainability, usually that is led to municipalities, local politics, and of course nations, etc. Those are the now, if you think about this as two sets of different powers, private versus public, at this point, private has all the power in terms of AI. And if sustainability is an actual goal, do you think that the nations should build, like within the political system, their own AI sources?
Yeah.
That's the $1 trillion question.
That's a
Arguable. Most companies, especially big companies, they have already made their net zero commitment. Like Schneider Electric also have made a promise, right? So actually, right now, at least in the United States, sustainability kind of things for supply chain are more driven by private sectors, especially right now. Of course, in Europe and in some other countries, it's a little bit different, right? So
I apologize. clarify my question. I meant in terms of environmental sustainability.
Yeah, so I'm talking about, yeah, environmental sustainability, talk about, okay, carbon emissions, right? So actually, most of the companies have already made this kind of commitment to reduce their carbon emissions to net zero by 2050 or 2040. So actually, they are leading that. So actually, there are also some issues with AI training data center. Based on the prediction, data center will consume 17% of our energy
Energy.
in this country. I'm just talking in the United States, projected right, by I think 2035 or something like that, 17%.
Yes.
So it's not really so AI training or data center. They are not so environmental friendly. They do not really generate jobs. So from that viewpoint, we have big concern about its impact on the environment and the social kind of issues.
Efficiency
Those are-
and redundancy,
yeah,
right?
So that's another thing about AI kind of big concern. Of course, many people also worry about the ethical issue about AI, how you can work together with people. You have already mentioned. So all those things also are very important.
Like I guess the example I have in my mind, like that works, I understand your point. I completely agree with you. But the example I have in mind, for instance, we are talking about transportation. I think you mentioned it earlier. I think the environment, my personal opinion, it could be wrong, my personal opinion, what is sustainable is public transportation. And there's nothing that stops, of course, municipalities investing in electronic vehicles that's going to be autonomous in the future, but that all will depend on AI and how things will fall in and cost, et cetera, et cetera. And in that case, if you depend on products for open source, are they going to have the same motivations as the general public? And how is that going to work in work?
Boy.
I think there's a
See,
lot of.
I'll tell you what, right? I think, okay, I think most companies are motivated by profit. Most companies, right? If you're not making a profit, what are you doing, right? So environment, just because there are a lot of companies like Bosch, right? Like the Tata Group in India, maybe there are others as well, that where it's all owned by, basically a non-profit arm, right? And so effectively all the profits go up and then they give it away to the communities they serve. But that is one way of looking at it, right? But when you try to say, okay, if I did this properly, right? If I didn't suck up so much, no, the almonds, you eat almonds, okay? All of us do. You know how much that almond costs you in terms of water? How much? Any guesses here? About 3.2 gallons for a single almond. Okay, so the amount of water that, and same thing is true for things like avocados, right? I mean, now it's going to quinoa, right? Because that's a great trend. So industry will continue to focus on what the consumer wants and how they can actually make it, right? And then they will say, use these terms as net zero and reduce carbon footprint and all that. But fundamentally,